Hi guys, in this section we're going to work on composition of functions. So when we have a composition, we're putting one function inside of another function. So the inside is g of x. So we're putting g of x inside f of x. So I'm going to take my entire function of g of x, which is x minus 12, and I'm going to replace it for x in f of x. So when I rewrite f of x, it's not going to be x squared, it's going to be x minus 12 squared. So x just got replaced with g of x. That's why it's not f of x anymore. We replaced x with g of x. And then it's asking us to simplify. So x minus 12 squared means x minus 12 times itself. That's what a square means. We don't distribute it, we times it by itself. So now I'm going to simplify x times x times negative 12, x times negative 12, negative 12 times negative 12, and combine like terms. And I have this one, the very first one. It's our simplified version where it's all multiplied out. Another way that we see compositions is with this circle. So it's not a multiplication because it's that open circle, but what that means, it's kind of the distributive property backwards. So I'm going to take f of negative 2, and after I find that, I'm going to put that inside g. So first, we want to find f of negative 2. So f of x is x cubed plus 7. F of negative 2 is negative 2 to the third plus 7. Negative 2 to the third is negative 8. Negative 8 plus 7 is negative 1. So now I know that f of negative 2 is negative 1. So now I want g of negative 1. So I'm working my way from the inside out. I just did f of negative 2. Now that is the number that replaces that. So g of x is x plus 8, but I want g of negative 1, so negative 1 plus 8, which is 7. So this would be my answer. So when you're working on compositions, you really have to think what's inside and what's outside, and you're putting either functions or values in to functions. So if you want to see more examples, you can ask me or Miss Hardy. Good luck, guys.